Resistance is about how easy or how hard it is for current to flow through a thing. So how easy it is for electrons to move around. So at an atomic level, that's about how easily the atoms that make up that material shed or attract electrons. So last week when we talked about thermodynamics and we talked about conduction and things getting excited and vibrating, we talked about the fact that in metals, electrons move around really freely. You end up with sort of a sea of electrons that lets things move around and vibrate well. In terms of electricity, what that means is that the electrons move around easily. It's easy for them to flow, and metals have a low resistance because of that. So it's easy for current to pass through metals, which is why we use metal for wire, and we use metal for things that we want electricity to go through. So materials like plastics have a very high resistance. They're hard for current to travel through, which is why we put plastic on things that we don't want current to travel through. So around the outside of our wire, we put plastic so that the electricity stays in where we want it to and doesn't come out and get us or things that we don't want it to be used on. All right, so like the plastic things, so that on a electric fence on the farm, so that the electricity doesn't connect with the posts and things and travel down to places where it's not useful, and stays in the wire where it can zap the cows and the trespassers. So resistance is about how easy it is for things to pass through. Okay. So when we talk about circuits next time, we'll talk about the fact that different things you place in your circuit have different levels of resistance. And we'll talk about placing those in series, so next to each other, or in parallel, kind of running side by side, which has an effect on the overall resistance of a circuit. So what things do you think might affect the resistance of an object? What things would we need to know in order to be able to calculate its resistance? Yep. So to work out resistance, we need to know. So the distance, so the length of the thing, yep, so we'll call that, or this one, L for length. I think we'll find that all quite satisfactory. What else do we need to know? Yep, the material. So, yeah, exactly. So that's what the material's made of, yeah? And we will call that P. And what else might matter? So if we think about a bit of wire, for example, so how long it is, what it's made of, and the area, how fat it is. So if it's really, really tiny, if it's got a really tiny area, the resistance will be higher, less things can get through, less electrons can flow through. If it's got a really big area, if it's a really massive wire, more electrons can physically get through there. So we're talking about cross-sectional area. Okay, so the resistivity, or the resistance of a thing, is equal to the material times the length divided by the area. So we can write that as that P-looking symbol times length over area. Okay. So there's tables and tables and tables that will tell you this value for different materials under different conditions. So like I said before, as resistors heat up, it becomes harder for electrons to pass through, and so they resist more. So current flowing through something generates heat, and as something heats up, its resistance increases. So its material factor changes, or the resistivity of its material, how much it's going to resist, changes. And resistance is measured in, somebody said it earlier. Beautiful. Measured in ohms. Can we use that little horseshoe for ohms? Okay, and then the last thing to say, just make a note of, is as the material heats up, its resistance increases. So far we know what charges are, we know what we call it when they're moving around, and we know what things stop them. So resistance, that provides stopping for that. So the next thing we're going to talk about is voltage, which is a measure of how much energy that current carries.